Hey guys, this video we're doing Math Quest 2012 Maths B, Chapter 8 AD question 14. Alright, let's get right into it. Alright, question 14. The graph at right shows the cross-section of a brick archway. All measurements are in meters. Good, so we know the unit is in meters. Alright, so let's look at the first question. Find the x-intercept of f of x. Alright, so this is f of x. And we're looking for the x-intercept. So this point and this point. Well, just like any other quadratic function, all right, so to find x-intercept, find x-intercept, we sub 0 into y. We sub 0 as y, or as f of x. As f of x. Therefore, we get 0 equal to 4 minus 1/4 x squared. Right? And then we got so negative 4. So we move the minus 1/4 x squared to the other side, becomes positive. Yeah, this one is better. So let's move that to the other side. By this is timing 1/4, so we move it by dividing 1/4. But you can also see this as this, right? They're the same. So this way is easier. Just multiply the other side by 4. Oops, 16. Alright, when you square root it, remember when you square root something, you get two answers, right? A positive and negative. So it's positive, negative 4. So right now we know the coordinate of these 2 points. 0, negative 4, 0, and 4, 0. Right? Like that. Good. Next, that's the first question, right? That's the first question. Find the x-intercept. Done. Done that. Second one, find the x-intercept of g of x. Alright, same thing. So find x-intercept. We sub 0 as g of x. Right? And then let's go. 0 is equal to 3 minus 1. Oh, this is getting repetitive, right? Same process. Bring the 1/3 x squared to the other side, become positive. Right? And now 1/3 times x squared is just x squared over 3, yeah? Move the 3 to the other side. And then square root it. And we get plus and minus 3. Right? So this point is negative 3, 0. And that one is 3, 0. Like that. Easy. Alright, and then find the cross-sectional area of the brickwork. So finding this. Alright, if you can see what I see, the cross-sectional area is just all the area under the f of x. Alright, all the area under curve minus the g of x AUC, area under curve. So let me use a different color. Yeah. So it's this bit. So all we need to do is just get the f of x area under curve from negative 4 to 4, and that will get us all the area, the whole thing, the whole thing here, all the areas, and then we just all we need to do is just minus the area under the curve of the g of x. We get the arc, we get that little thing in between, we get the area in between. All right, so let's do that. Okay, let's go. All right, I can do it. I can't move that, right? Okay. All right, so let's find out all the area of under f of x first, from -4 to 4. Okay. So from -4 to 4, f of x is always top minus bottom. All right. And some of you might wonder, well, where's the bottom function? Remember, the bottom function is this. This is the bottom. Oh, sorry. I wouldn't write bottom. This is y equal to 0, which is the x-axis. That's your bottom function. All right. So because we are still looking for area between two curves, right? Which is our f of x and the y equal to 0. Between these two lines. All right. So that's -4, 4. Top, which is f of x, it will be 4 minus 1/4 x squared, yeah, minus whatever the bottom function is 0. All right. I know it's not significant. You can always ignore it, but look, it is there. All right. My point is, it is always there. All right. It's literally just that. Ignore the 0. Now, 0 must be a lonely number. People always ignore it. All right, let's integrate. So 4 becomes 4x minus, all right, and let's take the 1/4 out, multiplied by the what do you call it? The integral of x squared is x cubed over 3. All right, the reason we can take the quarter out is because, you know, when you integrate something like that, you can literally take it out of the integral sign first because it's a constant, and then integrate x, and then multiply at the end. Yeah, like that. So that's just an example to show you. Let's just delete that. All right, so like that, and from -4 to 4. So that gives us 4x minus x cubed over 12, right? From -4 to 4. All right, let's put the numbers in. We get 4 times 4, right? Minus 4 cubed over 12. And then minus 4 times -4. Minus -4 cubed over 12. Right? 4 is 16. Minus 4 cubed is 64 over 12. Right? And minus 4 times -4 is -16. All right, negative minus -4 cubed is -64 over 12. Right? We can tidy things up a bit. All right, so that becomes -16. Negative become positive. All right, so that becomes 16 minus -16 becomes 36, so 32. Right, this is 16 plus 16. -64 over 12 minus positive 16 over 12. So that just become negative 128 over 12. All right, like that. Again, can we simplify that? Let's see, 128 divided by 12. Okay, so just 32 minus that give us 21 and 1/3. All right, that's the AUC under f of x from -4 to 4. All right, this is your x value. All right, we need the next one. We need the other one. The other function we are integrating from -3 to +3, which is g of x. So it's always top minus bottom. And in this case, the bottom function is the same as the one before, which will be 0. So integrate 3, -3. So the function, I believe, The quadratic function would be 3 minus 1/3 x squared. Yeah, let me double check. Yep, 3 minus 1/3 x squared. And then minus 0. Right? Don't forget that. I know, I mean, it's not significant, I said it, but still, it is there. Okay, like that. All right, let's integrate. 3 become 3x. Now we can take the constant out, 1/3, multiplied by whatever the integral of that is, x cubed over 3, from -3 to 3, and so that becomes 3x minus x cubed over 9, from -3 to 3. All right, let's go. Let's sub the numbers in. So 3 times 3 minus 3 cubed over 3 and then minus 3 times -3 minus -3 cubed over 3. All right, so 3 is 9. Minus 3 cubed over 3 is just 3 squared, which is 9. Minus 3 times -3 is -9. All right, -3 cube is -27 over 3 is -9, so it's -9. So this bit equals 0, right? Minus -9 plus 9. Right, -9 plus 9, which would be 0. So minus 0. Something went wrong. Let me check. Okay, I realized where the stupid mistake was. As you can see over here, it's x cubed over 9, right? I only wrote 3 over here. Silly, silly me. Silly, silly me. Should be a 9 here, right? So that should change this value and this value. So 3 cubed is 27, divided by 9 is 3, right? So same as here, right? So that's where the mistake was. Whew. I mean, when you get to 0 minus 0, you know that can't be right. The area can't be 0 because you can see some area there, right? So I'm just doing this to, to make sure you guys are listening. That's what everybody says when they make a mistake. Yeah, let me use that as well. All right, so it's 9 minus 3 equal to 6 minus whatever is inside, right? So this inside is -9 plus 3, so it'll be 6 minus -6 give you 12, right? Nothing wrong here. So this is the AUC, area under curve of g of x from -3 to 3. Right, so the area of the brick, is that what they call it? The area of the brick? The brickwork. Area of the brickwork is equal to whatever we got before, 21 1/3 minus 12. Which give us 9 1/3, right? 9 1/3, and it is an area, so it's meter square, right? So I forgot the unit here, so it's all a meter square and meter square, because we're going to find it for the areas, right? The areas. Okay, so that's the answer: 9 1/3 meter square. Oof. All right, that's all right. 15 minutes. All right, let's call it. Let's take a break, right? And we come back with commercial break. Remember, commercial break. Why some people might be thinking right now, why are you insisting on commercial break? Because I heard this when I was young. I heard this on TV a lot, and I thought it was cool. So right now I'm making videos. Might as well just keep the tradition on, commercial break. And who knows? I might be able to put commercials on. And yeah, who knows? Who knows what could happen? All right, so let's go into the commercial break right now, and we come back with question 15.